I gave you a list of prime numbers, at least the first few, and also give you a list of composite numbers. Remember, composite numbers are numbers that can be broken down. Prime numbers are the ones that cannot be broken down any further. Right, so 14 is an example of a composite number. 7 and 2 are its prime factors. So now 14 can be rewritten as 2 times 7. All right. Now let's do 84. What multiplication, Junior?
82 and 2.
82 and 2?
Yeah.
We're not adding.
42.
Two numbers that multiply to make 84.
42.
42
And 2.
and 2. That works.
21 and 2 for.
Oh, hold on. After 2 is a prime number, so we stop there. And 42 can be broken down to what?
21 and 2.
21 and 2.
And
Now,
7 and 2.
2 is a prime number, so that one stops. Then we break that down to
7.
and
3.
7 and 3.
And 3.
And those are prime numbers. So now, what is 84 equal to? The multiplication of all of its primes.
3 times 7.
So 2 times 2 times 3 times 7. Okay.
How do you know what that is?
Because we calculated it here.
Fast, so I
All the prime numbers being multiplied.
Oh,
All right? Okay, so now we want to simplify some fractions, but we've already done their prime trees, right? So we have, first question is 30 over 105.
he's offensive.
We write out its factors. We said 30 was 2 times 3 times 5 from this question we did together. So we write down 2 times 3 times 5 for 30. And we said 105 from our factorization was 3 times 5 times 7. This one here. Right? So we wrote those numbers with its factors. Now we cancel out factors that we see the same, comparing the top and the bottom. So what factors can we cancel out here? Julia?
7.
You're not Julia.
3 and 3 and 5 and 5.
Okay, so we have a 3 here, which can be canceled out of a 3 there. And we have a 5 here and a 5 there. And what are we left with? Is a 2 on the top and a 7 on the bottom. That is our simplified fraction. Right? A lot faster to do this than sort of sometimes working your way through the other way. All right? Okay. So let's do the next one. Rewrite 126 as part of its prime factors, which we figured out. Where's 126 here?
8, 12, and 12.
Oh, it's on the left. We said 126 was 2 times 3 times 3 times 7.
I was thinking 12.
All right, so 2 times 3 times 3 times 7 was 126. And we said 84 was 2 times 2 times 3 times 7. That 84 came from right here. So those are the prime factors. Okay, now we need to cancel. What factors are the same that we can cancel out? Mason, what do you see the same on the top and the bottom?
3 and 7 and 2.
All right, so it's 1 for 1. 1, 2 for 1, 2. All right? 1, 3 for 1, 3. 1, 7 for 1, 7. And what we have left over is our reduced simplified fraction. We have a 3 on the top and a 2 on the bottom. So 3 over 2. Okay. So writing prime factors takes quite a bit of energy. And it's not necessarily the most efficient way of doing things, right? But canceling out factors is a good skill to have for grade 9 and grade 10. Is how we simplify fractions that are not numbers.
I feel like this is pretty hard now.
All right? It isn't. All right? So instead of breaking numbers down to its prime factors, you can just break it down to any factor. Right? For example, 12 is 4 times 3, and I know 20 is 4 times 5. Right? Then I can cancel out the 4s. This is a 3 over 5. Right? There's lots of ways we can do these multiplications. I picked 4 times 3 and 4 times 5 because I knew in my head that I thought one step ahead. I wanted to cancel out the factor of 4. Right?
Wait, never mind.
Right? You could just simply divide the top and bottom by 4, but I'm just working with factors here. A different strategy. Okay? Now, how about 8 and 18? Can you think of some factor that you can get rid of both of them by? Logan?
You can do it.
9.
9 can't go
Oh,
into
wait, no, not 9. 2.
2.
That's what I said.
Yeah, because we can get 2 into both of them. So if I rewrote 8, then as a factor of 2, it would be 2 times 4. And if I wrote 18, that would be 2 times 9. Right? And the 2's cancel out, and you're left with a 4 over 9. That's essentially what we're doing when we say divide by 2 or divide by 4.
So
This is the step that we're doing in our head. But you just don't realize that, right? We break it down into its parts, then we cancel the things that are in common. All right? So that is it for the lesson, right? Except for there's one question on there that says, hey, can you give me something that's equivalent? All right? Remember what equivalent means? Equivalent means, can you give me the fraction that has the same value? Like all of these fractions are equivalent because they have the same value. They're worth the same amount. So how do you go between two equivalent fractions? You could divide the top and bottom by a certain number to go back and forth. Or you could multiply. So you can multiply this by 3. So 1 times 3 is 3. 3 times 2 is 6. That's why you can go back and forth between equivalent fractions. All right, and I'll come around and I'll help you. So I'll hand out your assignment, and we'll see how long that takes you.